This is pre-algebra lesson 8-2, part 2, equations with two variables. Now, prior to this lesson, all of our equations have been written in y equals form, which meant y equals 2/3 x plus 6, or y equals x minus 2, whatever, they were always solved for y. If an equation is not solved for y, to make a table of values, you need to solve the equation for y. So that's what we're going to do with these types of problems. We're going to solve each equation for y, and then we're going to graph it. So we have the equation 2x plus y equals 3. This is much like solving the equations that we did for a specified variable when we solved formulas for a specified variable. Same type of concept. We want to get y by itself. So the first thing we're going to do here is subtract 2x from both sides. These will cancel out. 2x and 3 are not like terms. So y will equal, in this case, negative 2x plus 3. Always put your equations in the form of y equals something times x plus or minus something. The term with the x needs to go before the term that is constant. You'll find out why in the next lesson. So we now have the equation in y equals form. So we have the equation y equals negative 2x plus 3. So I can put the negative 2x plus 3 in my box. Since there are no fractions, I can use negative 2, negative 1, 0, 1, and 2 in my boxes, which makes it nice and easy. And then I can just work through my problem. So I have negative 2 times negative 2, which is positive 4, plus 3, which is 7. I have negative 2 times negative 1, which is positive 2, plus 3, which is 5. Negative 2 times 0, which is 0, plus 3, which is 3. Negative 2 times 1, which is negative 2, plus 3, which is 1. And finally, negative 2 times 2, which is negative 4, plus 3, which is negative 1. I now have all of my coordinate points. My x value is negative 2, my y value is 7, x value negative 1, y value 5, etc. So I can plot them over here on my graph. I can plot negative 2, 7. And my graph only goes to 5. If that is the case, skip that part, go back to and plot all the other points, and just make sure that if you, when you draw your line, that negative 2, 7 would be on that line. So I can't really graph this one because it goes off my graph. So I'm going to start with negative 1, 5. Left 1 up 5. There's negative 1, 5. And then I have 0, 3. 0 up 3 is there. Then I have 1, 1. Right 1 up 1 is right there. And then I have 2, negative 1. The right 1 down 2. Now I need to plot my points or graph my line. Okay, so I'm going to graph my line here. Adjust this just a wee bit because I really missed on this one. Go use a ruler. I just don't have that option. Because I can't use a ruler on my board because it makes all kinds of other funny little lines. Make sure you put your arrowheads on your graph. And the last thing we should do, we should check and make sure that negative 2, 7 would fit. Negative 2, 5, 6. Yeah, that's about negative 2, 7. It looks like it fits on that line quite nicely. So we now label our equation y equals negative 2x plus 3. So the only difference between these equations and the equations you did the previous lesson is now you have to solve these for y before you can set up your x and y table. So you have to solve your equation for y, then set up your x and y table to graph. So let's look at another example. Y minus x equals 5. Again, we have to put this in y equals form. So the first thing I'm going to do is I'm going to add x to both sides of my equation. These cancel out, and I have y equals positive x plus 5. Okay, so there's my equation written in y equals form. Y equals x plus 5. I can put my x plus 5 here. Since there are no fractions, negative 2, negative 1, 0, 1, and 2. And now I'm just going to plot it in. If x is negative 2, I have negative 2 plus 5, which is positive 3. If x is negative 1, I have negative 1 plus 5, which is positive 4. If x is 0, I have 0 plus 5, which is 5. If x is 1, I have 1 plus 5, which is 6. And if x is 2, I have 2 plus 5, which is 7. If you're given a piece of graph paper like the one we have to the right, where the x and y axis are already drawn in for you, you should label them. I don't think I labeled them on the last one, so you might want to go back and do that. If you can't plot all the points, you must plot at least 3, because 3 points make a straight line, and ensure that you're doing the right thing. So let's plot -2, +3. So from the origin, left 2, up 3. Then we're going to plot -1, 4 from the origin, left 1 and up 4. Then we're going to plot 0, 5 from the origin, left to right none, up 5. And then we're supposed to plot 1, 6, which goes off our graph. But I have 3 points here, so I can graph my graph. And I'm just going to draw a straight line through those. That's a pretty good line right there. Lock that in place so it doesn't move on me. Draw my arrowheads. And last but not least, label my equation, y equals x plus 5. And there we go. Once we get into y equals form, everything else stays the same like we did before. Here's another equation. -3x plus 2y equals 6. This one's going to be slightly different. Not very much different, but enough. First thing I need to do, I need to get rid of the -3x by adding it to both sides of my equation. So I have 2y equals 3x plus 6. I don't want to solve for 2y, I want to solve for y. Okay? And we're used to doing this. The problem with doing that is it's really, really hard to figure out what the world you just did. Because now you're going to have to do a whole bunch of stuff and divide by 2. This y equals 3x plus 6 all over 2 is the same thing as saying y equals 3/2 x plus 3. All I did was separate this, so it was 3x over 2 plus 6 over 2. This is the preferred way to write your equation in y equals form, because now you know you need to use multiples of 2 to get rid of your fraction. So my equation in y equals form is y equals 3/2 x plus 3. So I'm going to have 3/2 x plus 3. So I know I'm going to need to use -4, -2, 0, 2, and 4. So I have, I'm going to put these in green so it's easier to see, 3/2 times -4 over 1. That would become, remember, 2 goes into 4 twice. So -2 times -3 is -6. -6 plus 3 is -3. Do these very carefully, otherwise you could end up with some really interesting answers. Then I'm going to have 3/2 times -2 over 1. That's going to become -3. -3 plus 3 is 0. I'm going to have 3/2 times 0, which is 0, plus 3, which is 3. 3/2 times 2 over 1, which is going to equal 3, plus 3, which is 6. And then 3/2 times 4 over 1. Okay. So it's going to be 6 plus 3, which is 9. Again, not all of these can go on my particular graph paper. If you have your own, you can draw your x and y axis longer, and then it would fit on your paper. Over my x and y axis, and then I'm going to plot my points. My points are -4, -3. So if you origin left 4 down 3, there's my first point. Then -2, 0. So left 2 up and down none. Then 0, 3. 0, 1, 2, 3. And then 2, 6, which is off my graph. And 4, 9, which is also off my graph. So then I can just plot those 3 points, which would be just fine. Draw my line really carefully here. That's pretty good. Tiny bit. And there we go. There's my line. Nice and neat, straight. I'll put my arrowheads on it. I will check and make sure that 2, 6 would fit. There's 2, 1, 2, 3, 4, 5. That looks like 2, 6 to me. So that looks like it's a decent line, and we can label our equation. Y equals 3/2 x plus 3. Always label your equation. Always label your x and y axis. And that is what equations with 2 variables part 2 is all about. All you're doing is making sure that you get these written in y equals form first, and then filling out your table length just like you did before, drawing your graphs just like you did before.